Good afternoon, everyone. This is Bahnishikha Das, Senior Lecturer in the Department of Civil Engineering from IIMT College of Polytechnic, Greater Noida. Today, we will be discussing a topic, quality of water, from the subject Water and Wastewater Engineering, which is in the 5th semester of Civil Polytechnic. So the quality of water, it is basically divided into three parameters based on physical quality parameters, chemical quality parameters, and biological quality parameters. So physical quality parameters are those which can be physically detected by our basic senses, like if we can, like basic senses like by our smell or taste or by our eyes or by our ear. If we can detect or we can sense any parameters, then those are coming under the category of physical parameters. Then chemical parameters basically, deals with the chemicals that is present in the water, any chemical compounds present in the water. And then biological parameters basically deals with the presence of microorganisms in the water. So, though all this studying all these three parameters is a vast topic. So today we will be discussing only the physical parameters of the quality of water. So before discussing the physical parameters, first we should know that why we need to know about the physical parameters or why we need to know about the quality of water. See, before supplying the water to various houses from these sources, the water needs to be assessed first, right? So the water is actually treated based on the quality of water only. So before treatment of the water, we need to first assess its quality. And based on the quality, we may not even require to treat the water. If we even require to treat the water, then the treatment also depends upon, I will say the degree of the treatment will depend upon the quality of water. So from the sources, when we are collecting the water, to distribute into various houses or various industrial or commercial areas, we need to first assess the quality of the water. And depending on its quality, we will decide its treatment, if the treatment is required or not. If it is required, then to what extent or to what degree the treatment will be required. Okay, so that entire treatment of the water will depend actually on the quality of the water. So before we go into the treatment, we must know the quality, like what it is, and that the quality is assessed based on the parameters. Like first, we will see the physical parameters, which can be easily detected. Then we will test or we will measure the chemical parameters, and we will measure the biological parameters, and depending on that we will go on the various steps of treatment. Okay, so physical parameters of water basically covers the turbidity, color, order, temperature, and conductivity. So we will be discussing all the physical parameters in detail one by one. So first, let's start with the turbidity of water. So in very layman word, I would say turbidity means nothing but like the cloudy water or the muddy water, I would say. Okay. So turbidity is nothing but the muddiness in water. So it occurs because of the presence of the suspended particles such as clay or silt or some other finely divided organic materials that may be present in the water. So because of its presence, the water appears cloudy or it appears muddy, which we can see with our naked eyes, right? So that is nothing but that is turbidity in water. So generally turbidity occurs because of the presence of clay or silt only. So it does not harm our health if the turbidity is not to a greater extent. Low turbidity does not harm our health. But we do not actually prefer turbid water because of psychological reason, because of aesthetic reason, because turbid water or the muddy water, the cloudy water, it does not look nice. So we will not be consuming that water, we will not be using that water for any other purpose. So for that reason, the turbidity, is assessed, and for that reason, the turbidity should be removed from the water. Generally, turbidity is measured in terms of milligram per liter or parts per million. So if the turbidity is up to 5 milligram per liter, so that water can be utilized because it cannot be seen or visualized with our naked eyes. But if the turbidity is greater than 5 milligram per liter, then that water actually looks muddy or it looks cloudy. So we will not be using it for any other purpose. So turbidity greater than 5 milligram per liter is generally not preferred, and the water should be treated. Next, coming to its measurement. Turbidity is generally measured in terms of silica scale. That means how much milligram of silica is present in 1 liter of distilled water. For example, if I say that the turbidity of a water is 5 milligram per liter, it indicates that in 1 liter of the distilled water, 5 milligram of silica is present in the water. Okay. So talking about its measurement, turbidity is measured by various instruments, which includes turbidity rod, Jackson's turbidity meter, Bailey's turbidity meter, and Nephometers. So turbidity rod is generally used in the field for measuring the turbidity of water. It can be used in the direct, like we can directly measure the turbidity from the source only if we use the turbidity rod. So this instrument, let me show you the instrument. So it's nothing but basically it's a graduated aluminum rod which it's required to be inserted in the water for which we want to measure the turbidity. As we can see in the picture only, there are some graduation scale. It starts from the bottom, it goes up. So, and there is a platinum needle. We can see a needle here. So that is nothing but it's a platinum needle which needs to be observed from the top position, top eye position. So what is done here is the turbidity rod is inserted into the water, and this needle is observed. This platinum needle is observed from the eye position. Okay. Now, depending on the turbidity of water, like we will keep on inserting the water until we see this needle. Okay, as long as we see this needle, platinum needle, we will keep on inserting the turbidity rod into the water. Now, at the moment when the turbidity, that needle is like we cannot see this needle any longer, that at that moment we will stop inserting the turbidity rod and we will measure the water level corresponding to this graduation, and we'll get the turbidity from there. Okay, wherever the point at which the turbidity needle is ceased to be observed, at that point we will stop inserting it, and at that point we will see the water level which is coinciding with the like will mark the water level which is coinciding with this rod, and we will take the graduation like the readings from there itself. Okay, so this is a field measurement which does not give a very accurate value of turbidity. It just give a rough estimation of turbidity. If we need to measure it accurately, we need to take it to the lab and do some like with the help of other instrument, we will have to measure it. So turbidity rod is used for generally measuring like taking a rough measurement of the turbidity of water. Okay. So next instrument for measuring the turbidity is Jackson's turbidity meter. So it also consists of a so you can see here, it consists of a graduated glass tube which is supported by a metal container, and that metal container is placed on a metallic stand. Okay, so this glass tube is transparent glass tube. It is like placed on this metallic stand, and below inside this metallic stand there is a candle. Okay, what we have to do here is we'll have to add water into this particular glass tube. From the top we will have to add the water, and from the top eye position we will see the flame of the candle. Okay, we will keep on adding the water until and unless this particular flame is ceased to appear. At the moment at which this candle flame will not be observed anymore, at that point we will stop adding the water and we will take the readings from the graduated glass tube. Okay, that will give us the turbidity here. But here there is a problem that, see, if the water is not much turbid, if the water is very less turbid, then no matter how much water we are adding into the graduated glass tube, the candle flame will be observed. So this particular instrument cannot measure a low turbidity, like it cannot measure a turbidity lesser than 25 milligram per liter. It can give a turbidity measurement if the turbidity of the water, if it lies between 25 ppm to 1000 ppm. So for that turbidity range, Jackson's turbidity meter can be used very widely for measuring the turbidity of water. So this measurement is actually based on the principle of scattering of light. See, because when we are adding water into this particular graduated glass tube, the candle flame will be observed, but well, adding more turbid water into the glass tube, the candle's flame will be ceased to be observed. That is because the suspended particles that are present in the water, they will reflect the light this light coming out, light rays of the candle tube, and that is why it will not reach our eyes and we will not be able to see the candle flame. So it is basically depend like this particular principle of measurement through Jackson's stability meter is the scattering of light. So if the candle flame is to be seen after a higher graduation, that means if we that means obviously the turbidity is low. That is why we are seeing the candle flame, even more and more water is added to the graduated glass tube. But if the flame is to be seen quickly after a very little amount of water, that means it indicates that the water is purely turbid, that water is highly turbid. That is why little addition of the water only the candle flame is to be seen, because more suspended particles are there and it is reflecting more and more light. Next, we have the Biley turbidity meter. So Biley's turbidity meter, basically, as we can see in the picture, it consists of a closed galvanized iron box. And on one side of the box, there are two glass tubes which are held vertically side by side. The section can be seen here. This A section can be seen here. And on the other side of the box, there is a 250-watt electric bulb with a reflector, so that it can throw the light on the tubes. These two metallic glass tubes, they are supported at the bottom by a white opal glass plate and a blue cobalt glass plate. So what happens here is we will fill, there are two tubes, right? So we will fill both the tubes with water. One tube will be filled with the raw water whose turbidity is to be measured, and the other tube will be filled with the standard water solution whose turbidity is already known to us. As soon as we switch on the light, as the light is lighted, the blue color will be observed in both the tubes because of the blue cobalt plate placed below the glass tubes. So as soon as we switch on the light, because of the blue cobalt plates which is at the bottom of the glass tube, both the tube will appear blue. But the water solution, both the water solution will be appeared blue. So what happens here is, if the color of both the tubes differ, that means the turbidity of both the tube is different. Since one tube is filled with the standard turbidity whose already value is known to us, what we will do is that we will replace the standard solution tube with another standard solution tube of different turbidity, and we will keep on continuing the process till the color of blue color in both the tube matches. Whenever the blue color in both the tube matches, that means it represents that the turbidity of both the tube is same, and we can get the turbidity from that value. Okay. So we will have to keep on replacing the standard solution, turbid solution, till it matches with the raw water sample solution. Okay, at the time when the standard solution will be matched with the raw water sample solution, at that time we can get the turbidity value from the standard solution. So this method can be used for precisely measuring the low turbidity of the order 0 to 2 ppm. So this that math, like the Biley stability meter, also we can see it also depends upon the scattering of light, reflection of light, because whenever the light is falling on the solution, on the tube, on the solution, because of the reflection of light only, we can see the color. Next, we have Nephometers. So Nephometers are the standard, like we can say, digital turbidity meter, which are used nowadays for measuring very low turbidity of, even we can measure the turbidity of drinking water samples also, for whose turbidity is up to 1 unit or less, 1 ppm or less. So it is based on the principle of scattering of light only. The sample will scatter whenever the light impinges on it. So the scattered light is then measured by putting a photometer at right angles to the original direction of the generation of the light source. Okay, so this measurement of light scattered at 90°, that measurement is called as nephelometry. That process is known as nephelometry, and hence the instrument is called as nephelometers. Whenever we measure the light which is because some light is being scattered and some light is being transmitted. So whenever we measure the transmission of the light, then that phenomenon is known as turbidimetry. Whenever we measure the scattering of the light, that phenomenon is known as nephelometry. So nephelometers is based on measuring the light, like measuring the scattered light. So that is why we call it nephelometers. So it's a digital turbidity meter, which will give the value digitally on, like the reading will be displayed on the instrument itself based on that principle. So these are the various instruments which are used for turbidity measurements. Nowadays, nephelometers is only mainly used for measuring the turbidity because it's a digital meter. It will give a very accurate value of turbidity of very low turbidity. Like if the even if the turbidity is very low for drinking water samples up to 1 unit or 1 ppm, that turbidity also can be measured using nephelometers. Next, coming to the next physical parameter, that is color. As we know that the pure water is generally colorless. So whenever we see any color into the water, that means it is due to the presence of some materials that is present in the water. Okay, whatever materials is there, that material is imparting color to the water. Otherwise, pure water is colorless, right? So that color can be due to the dissolved organic materials from the decaying vegetation or some inorganic materials such as colored soil, etc. It will impart color to the water. So colored water is also harmful. It may be harmful to us because of the presence of the materials which is giving color to the water. Generally, organic matter, the dissolved organic matter is present in the water. Dissolved organic matter is generally harmful to our human health. So colored water is considered harmful. So the color in a water, it can be measured by comparing the color of raw water sample with other standard glass tube, which is generally called as Nessel's tube, which is containing solutions of different standard color intensity, which can be measured in milligram per liter. So a standard unit of color is the one which is produced by 1 milligram of platinum cobalt in the form of chloroplatinate ion, which is dissolved in 1 liter of distilled water. So public supplies, as we may say that the colored water is harmful, so the color should be very less. It should be in cobalt scale, it should be less than, it should not exceed anyhow, it should not exceed 20, and preferably it should be less than 10. So next we have taste and odor. See, taste and odor are two different things, but generally they are always taken together while we're talking about the physical parameters, because both exist together. If there is any taste into the water, we will get some odor from that water as well. We know that pure water is tasteless or odorless. Like if there is, the pure water does not have any taste or does not have any odor. But if there is some taste or taste into the water, there will be definitely some odor into the water as well, which may be due to the presence of dissolved organic materials or inorganic salt or dissolved gases, which will impart taste or odor to the water. So the various gases responsible for imparting taste or odor into the water is hydrogen sulfide, methane, carbon dioxide, oxygen, etc. So taste and odor, as I already mentioned, that they are inseparable. So they are measured in a same unit that is known as threshold odor unit, often referred as TON. So it is measured by the formula is given A plus B upon A, where A is the volume of raw water sample in milliliter and B is the volume of distilled water. So what happens here is we will add water, or we will add distilled water to the raw water sample. Okay, and we will keep on adding the distilled water into the raw water sample until there is a stoppage of taste or odor. At the point at which there will be a stoppage of taste or water, at that point we will stop adding the distilled water, and then we will measure the TON value with this formula. Normally, as per Indian standard for public water supplies, the order, like the water should not be containing any taste or odor. So its value should be, very less, should be within the range of 1 or 3. Next physical parameter is temperature. So a temperature of, like for potable water, the temperature should be around 10 to 20 degrees centigrade, or at higher, like if it is more than 25 degrees centigrade, then it becomes objectionable, because if there is more temperature into the water, then the chemical or physical activity within the water, it increases. Like it says that in every 10-degree increase in the temperature, it increases the growth of bacteria or other microorganisms into the water by double rate. So higher temperature is generally avoided. So temperature is measured by ordinary thermometer. But in case of large body of water, the temperature is measured by using broken capillary thermometer. Next, we have conductivity. So actually conductivity, why conductivity is, it is taken in the physical quality parameters, because it is the total amount of the dissolved solid that is present in the water, it can be estimated by measuring the specific conductivity of water, and hence it is considered as a physical quantity because dissolved solid or dissolved salt in the water can be easily tasted. Right. So it is measured by means of portable dynamic water tester at 25 degrees centigrade, and it is expressed in micromoles per centimeter, which is then multiplied by the coefficient 0.65 to get the dissolved solid content or salt content in ppm or milligram per liter. So of course, conductivity, if more dissolved salt is present in the water, more salinity is there in the water, that means there will be more conductivity of the water. So public water supply, it should be nil, the conductivity should be 0. So these are the various physical quality parameters. As we can see that all the physical parameters can be easily sensed with our basic senses. So that is why they are considered as the physical quality parameters. In next lecture, we will be discussing about the chemical or biological quality parameters. Thank you.